Now let's take a look at arithmetic series. So it's a sequence of numbers that have a common difference, a common pattern between them that's either an addition or subtraction. So here I can see, for instance, that we are doing, well, this should, I think, say in 19. So yeah, here we go, 19, there we go. So yeah, it looks like there's a plus 5 going between every single term. So that is an arithmetic sequence, but because there's no commas, and there's now addition or sometimes subtraction, we can find a sum. So we're going to list a series of numbers, list a sequence of numbers, but we're actually going to be adding or subtracting all of those numbers together. So that's why this is called, this is a sum, and that is what is a series. A series will have a sum associated with it. So we're looking at a sum with arithmetic, adding, subtracting. So to find the sum of each series. So, I mean, you could just add all of these up here. So 4 plus 9 is 13. 13 plus 14 is 27. 37, 47, maybe 46. I don't actually know for sure. I'm just doing this on top of my head. So that was just that was just me adding all of these numbers up. That was me finding the sum. Now, is there a pattern here? 7, 7, 7, 7. So yeah, this would be an arithmetic series because our common difference is an addition of 7, and we are adding it. We're finding the sum of something. So then we got to add all of this up. So I guess 9 and 2 is 11 plus 16, 20, 27, 37, 47, 50. Maybe this is 80. Okay, so we could do this, but these sums will go on for a really long time. There could be a list of numbers that's 50 long, and I can't sit here and add it all. So there actually is a formula. There is a sum that we can look at for finding all of these things much faster. So here it is right now. I can zoom in on it. This says we are looking for the sum of some list of numbers. So we need to know how many numbers long. And so we can figure, well, how many terms are going to be in there? And then your first term. And so maybe we can write this. This is your first term, which you should already know. First term. This would be your last term. And of course, as I was saying before, n here, that is your number of terms. There's 2 spots for it. Okay, so, and I guess maybe this whole thing here is the total sum. It's the sum. So if you need to pause it here, you can while you write this stuff down. But I want to use this formula to see if I can get these same answers up here. So I have T1, that's my first term, so I'll write that T1 is equal to 4. And I have my last term, which we write as Tn, because we don't, well, actually I do know my last term. We usually write Tn anyway, so I'll just keep with that. I should maybe technically write T4, because it is the fourth, 19 is the fourth one, 1, 2, 3, 4. So it is the fourth term, but I'll stick with Tn. Our common difference is the previous number, or a number minus the previous one. So D is equal to, remember, T2 minus T1, which in this case could be 9 minus 4. It doesn't have to be. It could be 14 minus 9, but which equals 5, which we already knew. And the number of terms here, 4. So n is equal to 4. So this is all the information that we would have had looking into all of this stuff before. However, we don't even need all of that. So if I'm going to find the sum, Sn equals n T1 plus Tn all over 2. Now there actually is another formula out there, but this is the one that we're just using. So S4, the sum of the first 4 terms, is 4. No, n is the number of terms, which is 4, and then first term also is 4, plus last term, which is 19, all over 2. Now, I like to simplify the 4 and the 2 down here. Those can, the outside 4 and this bottom 2, those can be broken down to 2 and 1. So you probably see me do that a lot. That's a 2 and that's a 1. And then on the inside, 4 plus 19 is going to be 23. Now, we don't need the denominator of 1, so that's just done. And 2 times 23 is indeed 46. So that was just another way to find the sum versus just manually kind of adding all of those up. Now, also keep in mind, I didn't use the letter D. I found D, but it wasn't necessary. It was kind of necessary for me to prove to myself that this was actually a sequence of numbers or a series of numbers, making sure that they're all indeed 5, but I didn't use it anywhere in the formula. So let's double check over here. T1 is going to be 2. My last term is going to be 30. And how many terms do we have? We have 5. We don't always know how many terms we have, but this is so small I can just count them. And then I have a D, which we don't even actually need right now, which is going to be 7. 9 minus 2, which is equal to 7. Now, will I use that? Nope. But is it good just to check that this is 7, 7, 7, 7? Yes. Okay, so now I can actually do the formula for this. So I'll have S5 is equal to how many terms? 5 onto the first term, 2 plus the last term, 30, and then cut in half. Now I can't break down that 5 and 2 like I could the other one. I mean, yeah, it could, 5 and 2 could be, I guess, 2.5 and 1. So I'll just do this maybe a little more straightforward. I'll just start with the brackets. So 5 and then the brackets will be a 32 over 2. And here actually I can simplify it. The 32 and the 2, those can both be divided by 2. So I'll have a 5 and then I'll have a 16 and a 1. And then 5 times 16 is 80. So yeah, that does indeed work. So those are there's two ways to do this. There's adding them all up manually if you have that sort of time, and it only really works if you have all of the numbers. Or you can use this formula, which is a bit of a faster way to find this. So there's or. So you can use the formula or just do manually adding, which you'll never do because you have to find the sum of the first 40 terms. Like, that's just absurd. So I'll leave the video. I'll stop the video here. And the next one will actually do some questions that will require us to use the formula because, like I said, there's going to be 40 terms.